So, hello people, this is ThatITShow, today without the veteran, and we are going to be doing something a little bit different. My name is Yasmin, you probably know me, and I'm going to do inception thing today, and I'm to be going to install Proxmox, the virtualization solution that is right now one of the big solutions when you want to do open source, Homelab, and if you want to do something that actually makes sense. So I'm going to go through installing a small Proxmox cluster for the Homelab, of course, but the twist is that I'm going to do it in the Proxmox itself. So the idea is to use the Proxmox that I already installed, a single node Proxmox made out of single machine that I have laying around basically. And I'm going to install a 3-node cluster with Ceph, and I'm going to try to talk you through the installation and the necessary things that you need to know when you're installing something like this. So let's roll the intro. Welcome once again. The thing that I want to do today may sound stupid or let's say complicated. The reason is, why would somebody want to install Proxmox under Proxmox? My answer to this is, why not? The other answer is, you probably wouldn't install a cluster of machines inside a virtual machine that is a single node machine. But on the other hand, there is no other way to learn other than actually installing something and trying it out. So if you want to understand how clustering works, how to join a cluster, how to make machines work together, how Ceph works, how can you do things, I suggest that you go grab a machine that has enough memory, a machine that has enough CPU cores. And by enough, I mean enough to work, because you're not going to be running any real workloads on this Proxmox solution. But then again, you want to learn how to install it. And then after you're able to find enough of bare metal hardware, so bare metal machines, you can go and do the next step. And the next step is going to be, of course, to actually create a Proxmox cluster that makes sense. So you're probably going to go with multiple machines, multiple nodes, multiple disks, because if you want the Ceph to work, you need multiple disks. Also, you are going to be dealing with things that you need to know about the clustering and how the clustering works. By dealing, I mean you are going to be dealing with how to configure a cluster, how to configure each machine, and so on. Now, when you're ready for it, you're going to go with bare metal Proxmox, and this is the way that it should be done. Now, let's do a simplified version of how to create a 3-node cluster. First and foremost, what is Proxmox? Proxmox is a solution that is right now gaining a lot of ground for the people who don't want to risk using ESXi or risk using another solution that may or may become too expensive. At this particular point in time, ESXi still exists. It is not completely clear which part of it is free, which part of it is not free. You can still get ESXi virtualization hosts, but it is unclear what the future is going to be. If you are running a commercial installation, ESXi is no longer a solution for you, because there is no supported version right now. And by right now, I mean this may change the same way it changed with all the different clients and different solutions that the VMware provided, then decided that they're not going to be free, and then reneged on this idea, and then said, okay, this is going to be free for non-commercial use, but you still need to pay for commercial use. If you are using the commercially, Proxmox is also a solution that can be used, and the pricing is not that high. Now, let's talk about first what Proxmox can offer you, and then let's talk about what actually makes sense to install. So what you as a home labber, because this is my targeted audience today, what can a home labber do with Proxmox, and what can you configure and what can you expect from Proxmox? So what Proxmox offers on their website, and this is the thing that I'm running in the background, is the three different things. First one is the Proxmox virtual environment, so PVE itself. This is the actual Proxmox solution that everybody is talking about. Then there is something called Proxmox Backup Server. This is a solution that was intended to behave in much the same way as other commercial solutions such as Veeam look like and behave like. But this one is supposed to be open source. And then there is a Proxmox Mail Gateway, which is intended to be an open source mail security solution, as it said itself. And the idea is to just get your mails through this gateway if you are running anything that is a local mail server. So this can actually be installed as a mail proxy, and then you can deploy it in such a way as to stop malware, stop different things that you don't want in your or on your mail server. Now, I'm not going to be delving into what the backup server and the Proxmox Mail Gateway are. I'm just going to say that Proxmox Backup Server is something that is probably going to be covered in one of the next episodes. But for now, I'm just going to be concentrating on the Proxmox Virtual Environment itself. When it comes to the Proxmox thing, you need to know that this is an open source solution that can be installed in a couple of ways. By couple of ways, I mean if you're installing it, you can install it completely free. You can install it in a way that your solution is going to be free for you. You can use it commercially. But if you want to have additional things that the Proxmox can offer you, for example, training and support and so on, you can buy different licenses, and those licenses are going to provide you with some level of support depending on what you're buying. Now, if you want to know the prices right now while we are recording this episode, I'm just going to quickly go to the buy now and say, okay, buy subscription. And we can actually see what the different versions are. On the left, you can see that there is a community version, basic, standard, premium, and so on. This is a mail-related backup server. And different solutions come with different prices and different things that they offer you once you buy the thing. I would go with, if you are doing something this commercially, you probably want to go with the either basic or standard price, because this is going to offer you not only the thing that you want to do, access to the enterprise repository, but also the support tickets and so on. So support response time with 1 business day response. And this is going to be based on one CPU, and one CPU being one socket. So you're not buying the virtual CPUs or the cores. You're here buying this. The pricing is for one socket. You can of course go with the standard version, which is more expensive. It gives you the ability to create critical support tickets. So it gives you basically the idea, higher priority when it comes to support. Also, you get some support via SSH. So there is somebody who is going to connect to your machine and help you if you need support. Also 10 support tickets and so on. The lower tier is the community version, which is intended to be for the home labbers. And I would suggest that if you want to create your own home lab, invest in this project. It's not that expensive, especially if you are dealing with something like 2 nodes or 1 node. And I think that they deserve it, because you are getting the updates, you're getting the enterprise repository, but you're also helping them to develop this solution further, so that it actually makes sense for all of us who are trying to learn from it and try to work on it. And then once you upgrade, or if you, when you let's say advance to using it as a for-profit tool, so the tool that is actually something that you run from day to day in your business, then usually go with the basic solution. You can install it and you can use it if you are not using the any of the versions. You can, in a way, use the repositories, but the thing is that the repositories themselves are going to be, I would say, of a lower quality. But having experienced it and having played with it for a while, for a couple of years, I would go and say that even the repositories that are completely free, so the repositories that are not enterprise ready, are pretty decent if you want to learn how Proxmox works. So there is nothing stopping you from installing it. It is just that enterprise repositories can be used if you don't need the support tickets. Enterprise repositories are much cheaper to use when you want to use them commercially, and also they contain the software and the updates and everything else that the Proxmox team actually provided. So you can, up to a point, upgrade even the version that you don't pay for, but you are going to be limited in the availability and the stability of the repositories that are going to be used. Now, whichever version you choose, what you're going to do is you're going to just go to the installation part, and you're going to be just downloading the solution, or going to be just downloading the installer. And this installer is usually going to cover the current version, the previous version, and you're going to have some different things that you can actually go through. Now the current version is 8.3. I have installed or I have already downloaded 8.22 because I was preparing this a couple of weeks in advance, and this was updated a couple of weeks later. So I'm going to be installing the version 8.2, but it's basically the same, and then you can always install it and upgrade it later, even if you're not dealing with the enterprise repository. Once you get the license, and if you need the license, you can just paste it into the appropriate field in the cluster, and then your cluster is going to be able to be upgraded to whichever version you want. So this is going to be pretty simple when it comes to installing, and pretty simple when it comes to using it. And this is the reason why I decided to use it at the first place. Because what I have here is a cluster that is running my test machines. So these are server 1, 2, cluster 1, 2, 3, clients, and then another set of servers and clients, and so on. There are some CentOS-based machines here as a template. But the thing is that I'm going to be creating another set of machines. I'm going to be creating 3 Proxmox machines. And I'm going to be using it by using nested virtualization. So what I'm doing is I'm basically emulating or using virtualization inside the virtual machine. And as I said, you wouldn't do this on a normal cluster, on a normal installation that is going to be production ready, but you would definitely do it when you're trying to experiment with something. Because for experimentation, this is my experimental node. If anything goes bad here, I have the configuration ready, stored somewhere. I have the scripts needed to reconstruct this, because what I must say is also is this supports normal KVM virtualization, so you can use QEMU and all the other different utilities for it to create the machines from scripts. So I can redeploy this probably in a couple of minutes. So even if this entire thing doesn't work, I'm completely fine with it. Also, things that you shouldn't be doing is you shouldn't be creating a Ceph cluster like this one. If your Ceph cluster is going to be created out of disks that are on a single machine, this requires some tweaking, and this is completely wrong. I'm completely aware of this. The right way to do it would be to have multiple nodes and then have this Ceph cluster stretched across the nodes, because this is the way it is going to provide actual capability of being resilient to failures. Also, it is going to provide some sort of actual ability of syncing and keeping your data online even if one of the nodes of the cluster falls. So you would probably do this. Now, when we are talking about clusters, let me just preface everything that we are going to be doing with a big thing. When you are creating a cluster of any kind, try to keep all the nodes as similar as possible. With Proxmox, this is even more important, because what you can do is you can create machines that are, or you can use the machines that you have. For example, right now I have a machine. This is a AMD based machine with, I think, 64 gigs of RAM. Let me check. So this is a summary. So it is a Ryzen 9 3996 with 24 cores. So basically a 12 core processor times 2. It has 64, I think, 64 gigs of RAM, yes. And this is something that is AMD based. I could theoretically create another node that would be I don't know, Intel based, and I can create another node that is going to be completely different. For example, i9, or I would use, I don't know, a Xeon or something like this. But the thing that you don't want to do is exactly the thing that I'm talking about. So you wouldn't want to create a heterogeneous node configuration. And the main reason is because this is going to complicate your migration and the way that you're running virtual machines in a Proxmox. So if you need, or if you have a requirement to move the machine or migrate the machine from one node in the cluster to another node, you are going to be, it is going to be necessary to reconfigure the machine such that it uses the least common denominator when it comes to CPUs. So basically what you're going to do is you're going to be telling the machines to use the CPU that, when virtualized, can be run on both AMD and Intel in this particular example. And this is going to be slow, because this is going to require a lot of virtualization and a lot of features that the CPUs themselves are able to support, but the machine itself is not going to be. So if you have completely different architectures on different nodes, this means that you need to do the architecture that is the most common. And of course, this is going to be a problem, because when you do the thing like this, you're going to end up with slow machines that are going to be migratable from node to node, or your machines are not going to be able to migrate from node to node. So they are going to be you're going to be needing to shut them down, move them, reconfigure them, and then put them back up. This is sometimes not feasible, and also this is going to be creating some downtime. So when dealing with the nodes, try to always create the nodes that are similar or completely identical. Now, this similarity also should cover the disks. Ceph as a distributed disk idea is something that can work and is going to work with nodes that have different number of disks or different sizes of disks. And this is exactly why the idea of weight in the Ceph was created. But the thing that you want to do, or you don't want to do, is that you don't want to have nodes that are completely different, because this is going to create additional overhead when it comes to synchronized disks. Ceph uses the idea of trying to put different, they're calling it replacement groups. So they're using your data, when they're dealing with your data, they are separating it into pieces that they're called groups, and then those groups are stretched across different disks in the cluster. What you tell the Ceph when you want to have, I don't know, redundancy of 3, you're telling it basically that you want 3 separate groups to contain same data. Now, if your disks are going to be over a 3-node cluster, ideally your information is going to be stored on each node once, So if any of the nodes for some reason stopped working, you're going to have copies of the data. If one of your nodes is much bigger than the other when it comes to disk space, this is going to be the preferred node, of course, because there is not going to be enough space for the rest of the data. So Ceph is going to function, but it is either going to tell you that it is unable to perform the redundancy because there is no space for the groups themselves, or you're going to just be constantly swapping from this particular node into other nodes. But this is something that I'm probably going to dealing with in another episode. Right now I just want to go quickly through how to create a machine in Proxmox and how to create the Proxmox cluster itself. So basically what we are doing here is we are starting the installation of the Proxmox by showing you how to start a virtual machine in Proxmox. Now this is simple. As I said, this is a test cluster. So this is not a cluster, this is a single node. And this single node is called PVE. This is the default name for any node that we are going to be dealing with. Also, what I have here is, since I was doing something else, in the network thing, I have bridges that I'm using. I'm going to be using this bridge. This bridge is basically a closed bridge that is only linked to a local machine, so the machines themselves can talk between each other. And this is it. It is not able to go through the outside internet. I could theoretically use this VM bridge 0 that has an address and it is connected to a physical card in my computer, but I'm not going to. I'm going to create an isolated cluster, and this cluster is going to be using its own subnet in its own domain. I'm going to be using most of the defaults. Some of the defaults you may or may not agree with me on, and I'll try to explain this. If you have any questions, you can just talk to me in the comments. Now, let's quickly do the thing, and let's quickly put up 3 different nodes at the same time. If you want to create a VM, it's simple. In Proxmox, there is a button here that says create VM. So let's just push it. The node is going to be PVE. This is the placement of the node. So this is the machine that is going to hold my virtual machine. Since I have the only one node, and this is the one I'm showing you, there is only one node that I can choose. Then there is a VM ID. This is more or less just a serial number of the machine that is running right now. They get reused. So if you delete a machine, and then if your machine needs to be reset or redone, you can it is going to reuse the ID. The only thing that is going to be when your machines are up or created, ID needs to be unique. This is used all across the Proxmox. So if you are attaching a disk, if you are dealing with any kind of files, they're going to be including the VM ID of your machine. The name is something that is going to be basically up to you. I'm going to call my node PVE1 because this is the name for my machine that I'm going to be creating. Resource pool is something that I don't care right about now because I don't have pools configured. Since I don't have resources in pools, I have only one node. Next is going to be how to install the machine. I'm going to be installing from the ISO image that I already uploaded to the Proxmox. So it is going to try to tell me, okay, this is going to be a Linux, this is going to be a kernel, either a new one or the older one. This for compatibility reasons. I can theoretically use physical media, or I can say do not use any media at all, but I'm going to go with use the CD DVD storage here. Next, I'm going to be dealing with the system. The system itself is basically telling the Proxmox how the machines are going to be configured. So, is it going to have a graphic card? So I can tell it to create me a default graphic card, so a normal single graphic card. I could even go through configure it as a dual monitor, 3 monitor, 4 monitor VM, and this is going to create 4 different monitors that are going to be managed displays that you can connect to. This is useful if you need to do specific things. Also, what you can do is you could go and connect it to virtually connected to an actual GPU, or you can use the GL, OpenGL or virtual GL to connect to the GPU. So you could theoretically run this on a physical card. I'm going to go with the default. SCSI controller is also something that you need to take care. This depends, usually the defaults are completely correct. This depends on the operating system that you're using, in particular usage case that you need to use. I have absolutely zero reason to change any of this. Machine BIOS is something that you can go with either i440 or Q35. This means that you either go BIOS or UEFI. I'm going to go with BIOS. This is going to work, so I don't care about these settings at all right now. QEMU is the local agent in the machine itself. So if I install the QEMU agent in the machine, Proxmox is more capable of talking to the machine. So the Proxmox itself is going to be able to tell the machine how to utilize memory. The machine is going to tell the host operating system what is happening with the memory and so on. I'm going to skip over this. Now next, these are the disks. I'm going to go with the single disk of 32 gigs on the SCSI, and then I'm going to add additional 3 disks that are going to be basically the same on the same place. You would never do this when you're creating an actual machine. These would be physical disks. The reason why I'm using those is that I want to be able to create a Ceph cluster within the Ceph cluster. So I want to be able to create a solution that is going to mimic something that would be a 3-node cluster. You can also deal with bandwidth. You can do the limits for the reading, writing in ops, in megabytes. You can define maximal bursts for the ops and the megabytes. You could theoretically, you can separate disk into multiple threads in the Proxmox, but as I said, I don't care about any of those. The last one is the CPUs. I have 24 of those, so I'm going to go with using 6 cores grouped as one socket, and I'm going to tell it here that I want to use the host. This setting tells it to check what the host actually uses, and then to notify the guest operating system that it is using this particular CPU. So this means that this is going to be the closest to the host as possible. You could theoretically use different versions of the virtual machines or virtual CPUs, depending on what you have in your machine, or you could go lower, but I strongly suggest you don't. You either choose one of the emulated machines with some flags, so some capabilities, or you just choose host. Host is going to be the quickest one, but also the host is going to be the one that is going to create you problems if you have heterogeneous system, because the host means that your operating system is going to be seeing the actual CPU. So if you move the machine, the operating system is suddenly going to see another CPU with completely different set of features, and it's probably going to crash. Next, the amount of memory. I have lots of those, so I'm going to go with 192. I'm going to say network device is going to be my VMBR1. I'm going to say, okay, this is going to be para-virtualized. Okay, I don't care. Next. Now I get to confirm my settings, and I'm going to say finish. Now what I could do, I could theoretically go here and just clone it. And the reason why I could do it, and the reason why I'm going to do it, is because nothing is configured yet. So I'm just going to say, okay, clone this thing. I'm going to create it as VMID 110. It's going to be called PVE2. I'm going to say target is going to be the same as source. I'm going to clone it. And then I'm going to say, okay, clone it once again. And I'm going to be creating PVE3, same as source, clone. Before I start the machines, I'm going to just quickly check what happened. And this is where this part comes in. When I press PVE1, I can press hardware, and then I can see that I have 8 gigabytes of memory, 6 sockets, a BIOS, and I have 4 different disks that are called SCSI 0 to SCSI 3. I also have a network device. It is connected to bridge 1. and this is it. If I wanted in Proxmox, I could theoretically use Cloud Init, so I could create a configuration that is going to be applied to the machine through the Cloud Init. But the thing is that this requires the image itself to be Cloud Init aware, and I don't have this image. This is a Proxmox image, so I don't care. Also, you can do different things. You can tell it which boot order to use. You can tell it to start at boot yes or no. You can change all the settings that you saw here. You can do different things when it comes to hardware virtualization. You can disable it and so on and so on and so on. I obviously need this because I want to be creating a nested virtualization, but I could theoretically disable it. Now I have 3 machines here. The way that you see what the machine is doing is through console. Your console is going to be empty unless you start the machine. Once you press start, it's going to say this is the Proxmox, and this is the environment that looks like what we are installing. I'm going to go with Proxmox VE graphical. I'm going to wait a little bit. It's going to boot itself up. And then I'm going to double click on this. The reason why I'm double clicking and the reason why this is not working, I'm going to allow it. So this is a actual console window, but opened in a separate window. The reason why I wanted to do this, I can also click on the summary here, so I can switch this to something else and then go back to the window. The reason why I'm clicking this is because the console window inside the web browser is going to be compressed or is going to be resampled to the size of the window itself. This is going to be in the size that the console itself is configured in, so this is going to be much more legible to read. You can actually read from here, and it's much easier to read, especially in the stream. Now I'm going to agree with the EULA. I'm going to tell it, okay, I want this to be installed on the first machine, first disk. I could theoretically reconfigure things here, so I could say, okay, create root size, mean free size, and so on and so on. But as I said, almost everything is going to be defaults. I'm going to go with next. Country is going to be Croatia. Since I'm here, it is going to determine the time zone. This is useful, especially when you're running on the servers that are bare metal, because this is going to be actually a thing that you are going to be understanding, since you want to pass through the date and the time from the host machine to your virtual machines. So this makes sense to be configured. Now we need a password. I'm going to go with the most elementary password there is. So I'm going to say Proxmox, and then this doesn't need to be something valid. Also, I'm going to say this is going to be ThatITShow.com, and I'm going to go with next. It doesn't matter. The mail that I just put in is meant to be the mail of the administrator, so that the Proxmox environment can send you emails if this is configured as such. If you don't want the notifications, you can do any emails that you want. Now the host name is going to be PVE. I'm going to call it PVE1 because this is the reason I want to do. And I'm also going to also say this is going to be example.com, for example. Now my PVE1 is going to be number, I'm going to go with 10. Gateway is going to be 101. I'm going to be using DNS server 127.0.0.1. This is obviously going to be something that is going to be configured by you, depending on your configuration. Right now I'm completely winging it, so everything that you put in here is almost completely winged. Now it says, okay, install it. I'm going to quickly just grab this thing because I'm going to be using it once again in the next installation, and I'm going to tell it to install. Now while this is installing, I'm going to close the window and I'm going to do the next two ones in order just not to wait. I'm going to start the second one and the third one, and I'm going to do them in parallel. This one is going to be graphical installer. This one is going to be also graphical installer. And while I'm waiting for this, let me just quickly see what my PVE cluster is doing. I can see what is the server load. It's negligible right now. I can see the CPU usage. I can see the memory usage right now. And I can see the network traffic. Everything here is pretty normal. Even I would even call it laughingly low, because the memory is not being used that much. The CPUs are not being used that much, and but you can see that it is only using 0.8% of 24 CPUs. So the load itself is small. It is going to jump because these machines are going to be start to use the CPUs. But as I said, I don't care. I'm going to also say, okay, this is an hour averages, so this is fine. Now, PVE2 is hopefully booted. Yes, I can agree to the agreement. I can say next. I can tell it I'm in Croatia. I can tell it I'm in Zagreb. Next. Password is going to also be Proxmox. I'm going to put my password that I... Okay, that didn't copy it, but anyways, ThatITShow.com. I'm going to say next. I'm going to go with this one. Is going to be called PVE2. It is going to be number, let's say 20. The first one was 10. The second one is going to be 20. The third one is going to be 30. Next. Okay, it is not happy with the name, so I'm going to be changing it back to what I said on the first one, so example.com. Next. Next. Now this is it. PVE3. The same thing. I'm going to agree on the agreement. Say next. Say country is going to be Croatia. Next. I'm going to be putting Proxmox. I'm going to be saying that ThatITShow.com here. I'm going to be telling it that this is the PVE3 at example.com. It is going to be number 30. Next. And install. Now, the machines themselves should be installing in probably, I would say, 5 minutes a piece. Now the only thing that is a real bottleneck are the disks, because now every machine is trying to read from the same disks and write to the same disks. The cluster configuration that I created, so the self configuration, should alleviate this problem a little bit, but not by much, because we are using the same controller. This is a desktop machine, this is not a server, so the controllers themselves are going to be a problem. But as I said, this is a demo thing. You wouldn't be installing Proxmox on a cluster of virtual machines. You would probably use an actual cluster. Let's see what is the usage of the disk, what is the usage of the server. Nothing changed. We have some CPUs being used. We can notice some I/O delay because we are using we have I/O delay because we are using the same disks, so the disks are becoming a little bit of a bottleneck. Not a lot of memory is being used right now, so but this is fine. I would guess that this is going to be even worse. I was expecting it to be worse. Now the machines are installing. It should take a few moments, but as I said, I'm expecting something like 5 minutes apiece. While this is installing, let me talk quickly about how the Proxmox handles clustering. The idea of the Proxmox itself is, as you can probably see, the deb files here, so this is Debian based. What this is a Debian based KVM solution that is held together with the customized web interface. And the way it deals with clustering is extremely simple. what you get when you are using the when you want to create the cluster, you're going to be given a hash that is going to contain what is needed for the additional nodes, additional to the primary one. It's basically going to tell the additional nodes where the primary node is and how to connect to it. So it's going to give you the IP address and the necessary information that the node needs to connect to the primary node. Once this happens, everything is going to be fine. So you're going to see the nodes in the same environment, and then the appropriate storage devices and the appropriate things are going to be shown in the web interface. The thing that we are going to be dealing with, and this is a lot of things, is that we are going to be, once this is installed, we need to install also the storage. And this is probably the most important part when it comes to any virtualization solution, including Proxmox. What Proxmox gives you is that you can use all the normal solutions, or to be more precise, through the interface you can use all the regular solutions. Since this is a Debian-based thing, you can also configure anything as a local device. So if you have a fiber channel or iSCSI or NFS or whatever, you can either try to configure it to the Proxmox, depending on the solution that you're using, or you can simply just mount it somewhere on the file system and declare it as a local file system. What should happen is that if you are using something that is network aware, like iSCSI or NFS or Ceph, the Proxmox is going to be able to use it as a shared storage, so it is going to be able to do live migrations. Unless you are using the local storages, this is going to be the simplest thing that you can do. If you have only local storages, so if you configure only the local disks, there is no way for the nodes themselves to move the files among themselves. So this is going to create a problem, since you are going to be unable to use the live migration. But then it depends on what you're trying to do. I suggest that since we are dealing with the Homelab here and we are trying to experiment, you just try different things. Try creating a machine somewhere, try to create a machine that is going to be live and do something heavy when it comes to I/O, so do some heavy communication with the disk, or you can do a machine that is going to be heavy on the memory. You can create a database to see if it's going to get corrupted during the migration and so on. Depending on your configuration, what you're trying to do, just experiment, try to do things, especially when you are completely free to do whatever you want. Specifically, what I most like to do when it comes to any configuration and any testing, I specifically like to deal with the disks here, because they're not going to be quick. Okay, they're going to be fast enough. This is a SSD machine. Or even an NVMe, I'm not completely sure. But the thing is that they're not going to be quick enough, extremely quick. But what I can see is how the failure modes are affecting my virtual machines. So, for example, I could install in this cluster that I'm creating, I could install a small Linux machine, then see what happens if I fail a particular disk. Because since the disks are virtual disks on an NVMe, they're going to be pretty quick to respond. And then I can experiment. And the reason why I want to experiment is the main thing why the virtual labs like this even exist. And this is to learn how this is going to behave in the actual production environment. I want to go through disk failure modes and disk failure exercises and tests as many times as I can before I actually go into the production environment. Simply because I want to make sure that I know what to do. If my primary disk fails, or if a single disk fails in one of my servers, I want to be able to be completely sure in what I'm doing, how I'm going to do it, and what the results are going to be. So if I see that my disk is failing, I want to know how to replace it without losing anything, and also I want to have a peace of mind on how things work. So once you configure a thing like this, experiment. Try turning off the disks. Try deleting them when the machine is offline. Try to delete them when machine is online. Try to do different things to the disks. Try overwriting a particular disk with an erroneous command. Do something, because this is going to give you an idea, an insight on how your system is going to behave if something like this happens in production. Hopefully, this is going to mean that you are going to be able to do whatever you want to do and what you never ever need to do to recover the system itself. Now let's see how far along are we. This is on 72%. This one is at 69%. So the disks are the bottleneck, but fine, this is going to work. This one is going to be finished in a couple of minutes, probably. I would guess even less. How is my main machine behaving? I see high I/O delay, and this high I/O delay is more or less because I'm trying to do too much on the disks that are not intended to be used in such a way. Also, I'm using for this a Ceph cluster that is based on the 3 disks in a single node, which is something that actually needs to be reconfigured manually if you want to actually do it, because Ceph does not feel good when it comes to having everything on one node. Now, let me just, while this thing is being made bootable and then rebooting, let me just quickly go through one more thing. And this thing is the networking. What I have here is a virtual network. So everything is connected to everything else through virtual devices, and this is going to be as quick as possible. I can emulate extremely fast networks here, because what I'm doing is I'm creating just virtual machines, virtual networks that are connected through memory. In a real environment, if you want to create a shared disk of any kind, if you're using any kind of shared memory, you want to have your networking as fast as possible. Ceph is going to tell you that it should use at least 10 gigs, so 10 gigabit network, and if at all possible, faster network. You can get away with using 1 gig, but this is going to be an extreme bottleneck when it comes to using the Proxmox. So you should be considering, if you have any sort of a cluster, at least connecting all the cluster nodes between themselves with a separate storage network intended to only run the disks. And this network is going to be saturated almost all the time. Be aware of it and plan for it. And the reason why I want to tell you this is that I want you to understand that when you are configuring something like this, you are going to be dealing with a lot of different problems and a lot of different things that you need to think about, and the network shouldn't be one of them. So you should configure a network in such a way that your network is actually something that works. It should be something that is configured as a direct, or I would say direct, but probably through redundant switches. You should be able to configure the network that is as fast as possible, so 10G, 40G, or whatever you can afford. And then you should create a network that is going to be stable, and after that you should forget about this network. This shouldn't be your migration network, this shouldn't be your management network, this should be the network that you're using to connect to the internet. This should just be the disk or storage network that the disk use to communicate between themselves. Now, I configured my first virtual environment here, and I have my HTTPS running on the machine like this. What I need is, I would guess that I would need a single machine to run as my host that is going to be connecting to my web environments. So let me quickly pick up one of the hosts here. Let's see what this one has. Okay, this one is intended to do something else. Let me quickly spin up a host that is going to be web host for me, because I don't have a web host now. I'm going to skip a little bit. Okay, so what I did in the meantime was I was waiting for the PVA2 and PVA3 to boot. They booted. You can see that one is 100.20 and port is 8006. The PVA3 is 100.30 and 1006, so they have booted. And I also configured the server 1 because I wanted to have a machine that is going to be a client basically. I installed, or I had installed CentOS here, and just tried to quickly to set up the network so I can connect to the machines. Now, if everything is correct, I should be able to run the Firefox, and I should be able to connect to this machine. So let's try it. 168.100.10, and the port should be 8006. It should warn me, and it is, because it doesn't have any certificates. So I'm going to just go with advanced, and I'm going to say okay, accept the risk, and I'm greeted with my Proxmox login. Username should be root, and Proxmox should be the password. And it is going to warn me that I don't have a valid subscription for the server. Now, what you can see here is that I have a data center now that looks exactly like this one, but since this is embedded in the machine, I'm not going to consider right now that this is the primary center that I have. So I'm going to be calling this my first node. This is just the background or the backend that is running all my virtual machines. I can see that all of them are up, but I'm going to start ignoring them from now on. Okay, now also notice here that I have my node here. I have a local network, so there is networking that is done in the new. You can do SOTA networking in the PVE. The network itself contains only one VMBR, so there is one bridge connected. I see my local storage, and I see local LVM storage. This is small because this is these are parts of my boot disk. I didn't configure any of the rest of the disks. So first, what I'm going to do is I'm going to get the rest of the nodes up to my data center, and then after this, I'm going to go and configure the disks. How do I join all the other nodes? First, what I'm going to do is I'm going to quickly go using this address and this thing here. I'm just going to quick copy and paste, or to be more precise, I'm going to say, okay, I'm just going to quickly, not copy, but just quickly type it in. So 8006, the second one, advanced, I accept. I'm going to log in. This is my second node called PVE2, and now I'm going to go with 100.30 8006, the same thing, advanced. I accept the risks, log in, and this is it. I have my three nodes, PVE1, PVE2, and PVE3. Now the next thing that I want to do is I want to join them into one cluster. How do I do this? There is something called a data center here. When I click it, I'm going to see a tab or a subdivision called cluster. I can either create a cluster or join the cluster. Since I'm going to consider this my first node, I'm going to say, okay, I'm going to create a cluster. Now the cluster name is going to be something like PVE test. It doesn't matter. It says that the cluster network is going to be 110, and this is it. And I can just press create. What I'm going to get is, after this is done, I'm going to get something called creating a cluster. Okay, fine. And now I have a cluster, cluster nodes PVE1, and I have another button that says join information. This join information is going to give me, as I said, hash. I can copy this information into my clipboard. I can close this thing, and then I can go to different nodes, go to data center on those nodes, and let's just say join cluster. It is not going to ask me for anything other than just to paste the encode information. That it is going to decode the information, tell me the peer address is going to be 110, the password needs to be Proxmox in my particular thing. This is a fingerprint for this information, and I can just say, okay, join it. Okay, and now it is stopping the cluster service, and it should be telling me that the cluster service is going to be fine. Let me just show this. Let's go here, and I'm going to see the node appearing here. So the node is trying to join the cluster. Now I can see the green check mark here. So the node joined the cluster, and now I can see that my data center has 2 nodes. I am going to go back to this node. It says that invalid PV ticket because this node right now is reconfigured and is part of the cluster. And I can reconnect to it, but now I don't need to, because everything that I can do on my PV1, I can also do on PV2 while joined to the PV1. So they're all part of the same cluster, so I can do reconfiguration from one site. I'm going to do the same with the PV3s. So I'm going to go to data center cluster, join cluster, paste my information. It's going to say, okay, the same thing. Proxmox is my root password. Join request, okay, finishing setup locally, okay, and then I just go here and wait for this thing to appear. So it is going to go from forbidden to unknown to checkmark, green checkmark that says, okay, now I have a cluster. And this is it, I have a Proxmox cluster. Now the next thing that I wanted to do is I wanted to configure Ceph. I'm going to just quickly go and check, am I even able to do this? I'm going to say, okay, on my PV1, what can I do? Do I have my disks? I'm going to go into disks and see that I have my separate disk here. They are not used, so no. These are the names. These are the serials on where they're connected. So I can see that my disks are here on my first node in the cluster, on my second node in the cluster, and my third node in the cluster. The next thing would be to check if my first node in the cluster has Ceph configured. And this is going to say, okay, do you want to install now? I'm going to click install Ceph, and it's going to say, okay, I'm going to now go through the installation. I can choose the version. I'm always going to go with the latest one. I'm going to go with the no subscription one because I don't have the subscription. So this is not the best choice for production setup, but I'm going to be completely fine with this. Now I'm going to start with the Reef installation, and then it is going to try to configure go to the internet. Since my nodes are not connected to the internet, there is no way for me to install it right now. So what I'm going to do is I'm going to end this episode on this cliffhanger, and then I'm going to, in the next episode, reconfigure the networking, do the internet, create the internet itself, and then we're going to join the cluster, join the Ceph, and then create shared storage. So in the next episode, expect more of Proxmox shenanigans. Expect me to configure the Ceph cluster to show you how to deal with the Ceph and how to open different things in Ceph, and also expect me to show you how the upgrades, the cluster, not only the Ceph one but the Proxmox one are done, and expect that I'm going to be running the new the first virtual machine. So I'm going to be connecting to the internet and doing something to connect to the first virtual machine. Until then, see you. Thank you.